This programming is just one way we bring to life our alumni board mission, which is to foster relationships that benefit our college, alumni, students, and friends by sharing with all of you the awesome and important research that's going on in CFANS. So thanks for joining us. We really hope you enjoy the program. If you have participated in the past 2 virtual programs, I'm really excited to share that we've changed things up just a little bit. Our keynote presentation will begin with Heidi Roop, and that's going to be followed by 3 lightning presentations from faculty members across the college. We have Pam Ismail, Yuxin Miao, and Susan Galatowitsch. And then we are bringing a new interactive element that will follow the presentation. So there's going to be 4 breakout rooms, 1 for each presenter, to give all of you the opportunity to engage with our speakers, to ask questions, to share a conversation. So those rooms will be open for 15 minutes, and you'll be able to move from room to room if you would like. Finally, we will wrap up with some closing remarks in the main Zoom session. With that, it is now my pleasure to welcome our CFANS Dean, Brian Bohr, to share some greetings from the college.
Good, thank you, Annie, and thanks everyone for joining us today. I'm Brian Bohr, I'm Dean of the College of Food, Agricultural, and Natural Resource Sciences here. And today might be one of those days where it's just worth saying the whole thing, because our program today, as Annie said, is about climate adaptation and climate change. And given the diversity of our work across those areas, this group of faculty is pretty representative of how we come together to bring possibly solutions, but also just knowledge and education regarding the areas that we span, with climate adaptation being one of our greatest challenges going forward. Before I move into that, though, I do want to again welcome you all, and we're delighted. I think it's supposed to be springtime here. It doesn't certainly feel like it, but we do know it's coming because we're wrapping up our semester, and we're really excited that we have our graduating class graduation coming up in May, and we're really excited to be able to do that in person this year. This will be the first time in 3 years now, 2 years we didn't have in-person graduations, and so we're really excited about that. And we are inviting some of our other graduates back if they wish to attend graduation. So we're excited about that. We all look forward to it, and it's great to be getting back into the theme of things. Beyond that, Class Without Quizzes has been a tremendous way for us to think about how our work connects to the broader community. So having you all here today is a way for us to address that. As Annie said, and Mary indicated, we have some extraordinary faculty here today, award-winning faculty. In fact, one of the awards most recently that's a broad award we're very excited about is a grant for Climate Adaptation Center, the Midwest Climate Adaptation Center, which will be housed here at the University of Minnesota. And it actually engages not only our faculty, but one of our strengths, I think, as a college is we function within a broader university. It has a tremendous scope of research and science that we can bring to these challenges. And I also always want to emphasize that a lot of the work you'll hear about today, as we think about it, is occurring not just in our labs here on campus and not just in theory as the work we do, but we take it out into the world. And so the work that we'll see from soil, water, climate, from fishes, wildlife, conservation biology, from food science, nutrition, is really engaging out there with the broader community in achieving these goals. Because with climate adaptation, of course, it's going to require not only that we have the science to adapt to, but that we also have the people available to engage in this work to change their behaviors and change the outcomes of communities. We do work across, in this area, I'm sure we'll hear a lot about our research and outreach centers that are across the state that allow us to work between fields and forests and animals across the state. We've just made significant investments in those because one of the things we think about is climate shifts, the landscape specs, climate shifts across it. We have the ability to look at different parts of the state and regions of the state and really the Midwest and see how this impacts that more broadly. So having said that, I'm simply the lead into this. What's much more interesting is the work of our faculty and students and staff working in these areas. I'm just delighted to welcome you all here today, and I will turn it back over and so that you can all be introduced, and we'll have a great class lot quizzes. So thank you all for joining us.
Thanks, Brian. So I will introduce our keynote speaker, Heidi Roop. Heidi's an assistant professor and an extension specialist in CFANS. Her professional mission is to improve the reach and impact climate science in order to engage, motivate, and catalyze action around climate change. Heidi combines climate science and science communication to connect climate change information to decision makers and communities across the Midwest, US, and abroad. By producing actionable, relevant climate science, Heidi helps diverse stakeholders prepare for a changing climate. Heidi aspires to be a scientist who changes how the world engages in science and with scientists. Heidi has used her science communication expertise to help organizations like NASA, the National Science Foundation, the Exploratorium, and the Washington State Department of Ecology more effectively communicate their work. As Heidi shares her presentation today, please save your questions for the breakout rooms after all the speakers have presented. Thanks again and welcome, Heidi.
Thank you so much for this opportunity and for all of you joining today. I have the distinct challenge of having 10 minutes to compress both an extension and research program and the sort of broader context setting for what my colleagues will share with you in regards to their incredible research projects. So as you just heard, I'm Dr. Heidi Roop. I'm a new assistant professor and extension specialist. My faculty home is the Department of Soil, Water, and Climate. And I have the great privilege of leading the expansion of a program that is jointly held by CFANS and Extension called the Minnesota Climate Adaptation Partnership. And we work with a variety of organizations, tribal entities, nonprofits, private sector partners, and others to work to advance the integration of the climate science and research knowledge into the landscape. But more importantly, we work with partners to understand what challenges and solutions are actually needed and how we can best leverage university expertise and resources in service of those solutions. And so really true to our programming and our approach is this idea of partnership. And I will tell you a little bit about sort of the broader context of why we need to be investing more in this idea of partnership to advance our both reducing the problems of climate change, but also preparing for the changes we've set in motion. And you'll get to hear from Sue Galatowitsch as well about our broader involvement in hosting the Midwest Climate Adaptation Science Center as well, which is a university federal partnership. The Climate Adaptation Partnership within CFANS and Extension, we sort of have 5 programmatic priorities. One of them is to provide trusted, regionally relevant climate information. We're really fortunate to have support from the Minnesota State Legislature to develop unprecedented resolution of future climate data for the entire state. We are underway in that project right now, and by next year, we will be able to provide every community in Minnesota and state agency and farmer and individual homeowner or landowner with information very specific to their own climate risks. We also support adaptation planning and offer training and help close the gap between research and practice. We also spend a lot of time investing in developing peer-to-peer networks and sharing best practices because we know that research is one element of what it means to do good work and to work towards solutions. We also have to leverage the different knowledge and expertise that exists in our communities and with our partners. And so we really work to foster those relationships. We also convene leaders from around the state through regular extension programming, and we champion adaptation leadership by giving out awards. This last year, with support from 3M, we honored 5 incredible leaders from across our state who are making real leaps and bounds and helping our communities prepare and respond to the impacts of a changing climate. And of course, true to our mission at the University of Minnesota, we invest in climate literacy, and this takes a variety of forms for our organization, from working with K-12 audiences to deeply engaging the media and providing elected officials with the support they need to understand how to manage climate risks for their constituents. So just to set the context, because you're going to hear sort of 3 very specific examples of how we are working together to both prevent the problems of climate change from getting worse, but also prepare for those changes we set in motion. And those are really mitigation and adaptation. And I'll unpack those a little bit as a lead in to the lightning talks. But what I want to do today is sort of provide you with the sort of, this is the classes part. And again, there's no quiz. But what I've done for us today is sort of synthesize 2 very large, robust state of knowledge reports we have in the global science, climate science community that have come out of the Intergovernmental Panel on Climate Change. One at the end of 2021 that was really a synthesis of our state of knowledge related to what we understand about climate change and its impacts globally. And then another report that just came out in recent weeks, specifically as it relates to this imperative, but for both reduce emissions, but importantly, adapt, prepare for those changes we set in motion. And this simply summarizing thousands of pages of research, hundreds of scientists' time and effort, and again, these sort of thousands of peer-reviewed studies. These are the key take-homes that I have for you all in terms of our state of knowledge, both as it relates to climate science and adaptation. And I'll unpack each of these very briefly for us here to give you a bit more to hang your hat on. So we know very clearly the source of the problem when it comes to climate change, and that's us. And that actually is a real opportunity. If we know what the source of the problem is, it makes it much easier to deploy solutions. We also know that a changing climate is no longer something far off in the future. It's something here and today that we are all experiencing and living through. We also understand that the impacts of the human-caused climate change are showing up everywhere around the globe. Science also suggests very clearly that we know we've committed to change. So we've locked in change. And this is where that preparation piece is so fundamental. We no longer get to just focus on mitigation or the reduction of emissions because we know we have a different climate future coming our way. However, we also know that the more we emit of greenhouse gases, the worse it will get, both in terms of the societal costs and consequences, as well as how much we're going to have to respond or how much damage we'll have to prepare for. We know very clearly that we have to reduce risks that are posed to our communities, to our landscapes, to our ecosystems, and to our economy through adaptation. And as you'll see, this can take a variety of forms. And I think most importantly, we can still choose, but there is urgency to our actions. And I think the research you're going to hear about today is really leaning into both the science, but also this urgency and this opportunity that we have, because the choice really is still ours in terms of what the future looks like. So it's us. This is the strongest statement that the Intergovernmental Panel on Climate Change has come out with since its inception related to the cause of the warming that we are observing, and that it is unequivocal that human influence has warmed our atmospheres, our oceans, and our land. And we know that the rate of warming is unprecedented in at least the last 2,000 years. And this sort of historical geologic context is actually a big focus of my previous research prior to joining the University of Minnesota. So I'm excited to see both the past records really informing our understanding of how different today is from the past. We also know that there are clear connections between human-caused climate change and changing patterns and extremes. So not only is our global atmosphere and our oceans and our land masses warmer, we're seeing things like heat waves, heavy precipitation, drought, and tropical cyclones all worsen as a consequence of human-caused climate change. And importantly, it's really easy to dismiss these things when they feel very far away and on a global scale. But here also means Minnesota. And so while the global average temperature has increased nearly 2 degrees Fahrenheit since the late 1800s, Minnesota's average annual temperature has increased by nearly 3 degrees Fahrenheit since 1895. And those data come from direct measurements collected by folks around the state for over the last 100 years. We also see Minnesota's climate getting warmer and wetter, and we know that our communities, our businesses, our farmers, our tribal nations, and others are all navigating these extremes and really working to both respond and prepare for these impacts. We know that weather and climate extremes are causing economic and societal impacts across boundaries through supply chains, which is something we're hearing a lot about and something a lot of Minnesotans had to navigate this last year, not just because of COVID, but because of climate-driven events. We're seeing impacts on our markets, the flow of natural resources, and this, of course, is touching sectors including water, energy, and food, and thereby all of us and the lives that we live. We also know we've committed to change. So we know that the planet will continue warming and we'll continue to experience the impacts of this warming until at least mid-century. We know that even if we just turn off the tap of those greenhouse gases like carbon dioxide and methane, the planet will still respond to the warmth that we've produced through the contributions of greenhouse gases we've already made. This plot is just showing you potential trajectories of warming out into the future to the year 2100. And we know they all share a common pathway, which is continued warming, but I'll discuss sort of where this divergence in the path comes at the end of the century, which is really our opportunity and the opportunity we have today, and critically the opportunity that the researchers you'll hear from today are embracing. They're working to develop solutions and deploy those so that we have a better outcome for reducing warming in the future. And most simply, you know, the relationship between carbon dioxide or greenhouse gases and the atmosphere and warming are very clear. And we know very simply that the more we produce of greenhouse gases like carbon dioxide, methane, nitrous oxide, we know the planet will warm and the worse it will get. And so we still choose. Here, showing you a graph of the potential outcome based on the production of emissions moving forward in time. So starting today, depending on the pathway global society chooses, we could end up under very high emissions with a planet that between the 2080s and 2100 is anywhere between 5 to 10 degrees Fahrenheit warmer than the pre-industrial period around the 1850s. Conversely, if we adopt a very low emissions pathway, we could actually bend the curve and limit warming to below where it is currently, or just slightly above the global average temperature change that we've already experienced. Science and policy suggest that we're going to end up somewhere in the middle, and right now sort of nearer that higher end than the lower end, but progress is certainly being made. And so that very high emission scenario is an unlikely scenario. It would require ramping up emissions, which is not what many global climate commitments represent. All in all, how we feel these impacts in Minnesota or in any community, and of course the system-based impacts across our globally connected society depend on both how well we prevent further warming, and this is mitigation, the reduction of emissions of greenhouse gases, and paired with how well we prepare for the changes we've set in motion. And when we balance and invest in those two things, we are more apt to have climate-ready communities, infrastructure, ecosystems, and thriving communities, right? In alignment with the mission of the University of Minnesota. And of course, Extension, which is really working to deliver research in service of a bright and thriving future for all Minnesotans. So just briefly to unpack this jargon, and you're going to again hear more from my colleagues on really specific research examples. As we think about mitigation of climate change, you hear mitigation a lot. This is really the reduction in the sources of those greenhouse gases or enhancing the sinks, storing those emissions that get produced or are already in the atmosphere in things like soils or in trees. And so that is mitigation. When we say mitigation in this context, this is really the prevention piece of that equation. Importantly, and fortunately, we understand the primary sources of global greenhouse gases globally and also within the US. And this is just showing you a snapshot of global greenhouse gas emissions by sector. We see, of course, energy, the energy industry, it makes up a bulk of the pie. This is industrial application, transportation, and energy use in buildings. We understand that our agriculture, our forestry, and our land use practices also contribute to emissions. We know that our waste processing also contributes to emissions, and then we have other industrial activities like cement that add another layer of emissions. And so the reason I show you this is that this is the opportunity. We know that there are solutions for this mitigation piece embedded in all of these sectors and industries. And so it's not, there's no one size fits all. There's also no single actor that has to do the whole lift. We need to see action and mitigation across all sectors. Mitigation takes many forms, but this is primarily, and this the science from the IPCC shows this very clearly, it's rapid decarbonization. That means reducing the combustion of fossil fuels through our activities like transportation, home energy use, buildings, the built environment, our shipping and transportation sectors. And then again, enhancing the ability for our working lands to store those emissions or to be a factor in both mitigation and importantly, adaptation. So some of our actions, and some you'll hear about today, are really both. They represent both reducing emissions as well as actions that help prepare our landscapes and our communities for the new climate future we expect in the state and globally. And so adaptation really seeks to limit or avoid harm and facilitate adjustment to new expected climate changes and its effects. And so what does that mean? Just like mitigation, adaptation comes in many forms, and it's needed both across natural and human systems. Adaptation can be using future climate information to make sure as we design roads or bridges or our transit systems or our healthcare systems, that we're factoring in a new climate future. Many embedded assumptions about climate go into decisions that are made every day around our wastewater utilities, our roads, our healthcare, how we manage our lands, what lands we conserve or preserve for habitat. And we know that adaptation, and you'll hear some concrete examples of this, can need to show up in all of the work we do, whether we're thinking about our universities buildings and how to make those not only more energy efficient, but also resilient to the warmer and wetter conditions that we know we're going to have to experience and navigate through. to thinking about what does it mean to build strong social ties and communities so that our individual communities and our own personal families are resilient to these impacts and these changes. Climate change threatens not just built environment, but also our social infrastructure and our cultural identities. And so as we think about adaptation in our program and other programs at the university and within CFANS, we think broadly, not just about the built environment and the natural environment, but the intersections and interactions of those two and what it means to be a human living and thriving in a climate changed world. And so finally, we know we can still choose, but this is a quote from this most recent Intergovernmental Panel on Climate Change report, and I think it sums up quite nicely the main point, which is the urgency point, and I'll just state, any further delay in concerted anticipatory global action on adaptation and mitigation will miss a brief and rapidly closing window of opportunity to secure a livable and sustainable future for all. And I'll close with that. There's no time to waste, and I'm sure you'll be inspired by the lightning talks you'll hear now, which are very specific examples of how CFANS is showing up to help make sure that we're working towards a livable and sustainable future for all and all Minnesotans. Thank you very much.
Heidi, thank you so much for sharing a great summary of some of your work with us. We just really appreciate your perspective on the urgency to act and adapt to climate change. Next, we look forward to hearing a lightning talk from Pam Ismail, professor in the Department of Food Science and Nutrition and founder and director of the Plant Protein Innovation Center at the University of Minnesota. Pam has over 25 years of experience in food chemistry research, focused on analytical chemistry, protein chemistry, and chemistry and fate of bioactive food constituents. Her research focuses on chemical characterization and enhancement of functionality, safety, bioavailability, and bioactivity of food proteins following novel processing and analytical approaches. She's also the recipient of a Distinguished Teaching Award and an Outstanding Professor Award. Thank you so much, Pam, for joining us today.
Thank you, Annie, for the introduction. It's my pleasure to be here today. And also, I would like to thank our keynote speaker, Heidi, for a very inspiring talk today and bringing awareness to climate change. And I want to focus today a little bit about what we do here that is related to climate change. And the first thing we think of here in the Department of Food Science and Nutrition is food, right? And how we produce food impact our climate big time. And because of the awareness from consumers, they started looking at diversifying their sources of food to help mitigate environmental changes and impacts. So there comes this huge change on huge demand for plant proteins as proteins that potentially can help the environment. So we're thinking here about regenerative agriculture and how we can utilize regenerative agriculture to produce foods that would provide healthy alternatives to current ways or current diets. So today I'm going to talk very briefly about global demand concerns and opportunities related to plant proteins. I'll start off by giving you a little bit of understanding about the demand and giving you some numbers. So if we look at in 2020, the global protein ingredient market was valued at $38.5 billion, and it's anticipated to grow at a very steep rate of 10.5% from 2021 to 2028. So that's huge and steep and not going to go anywhere in the future or in the near future. And specifically the market, if we look for plant protein ingredients, it's expected to reach about 3 billion by 2029. So the global pea protein, and I focus a little bit about pea because it's growing so fast. One of the most or fastest growing markets is the pea protein market. And it's valued in 2019, it was valued at $130 million, and it is estimated to almost double by 2026. So if we look at reasons behind this steep interest in plant protein, and I usually divide it into two perspectives, the consumer perspective and then the producer's perspective. From a consumer perspective, there is growing interest, obviously, and understanding of sustainability and environment and the impact on environment and climate change. So the consumer is becoming very much aware and seeking alternatives that come from sustainable and environmentally friendly sources. So they are concerned about animal welfare, and they are concerned about their health as well. And they associate plant-based diet with a healthy diet. And we see because of that a surge or increase in the percentage of people that identify as vegetarians or flexitarians. And you might wonder what flexitarian is. I am a flexitarian, for example. I prefer when I go to a restaurant to eat plant-based or vegetarian, but I would eat sometimes chicken meal. Rising incidences of allergenicity. This is becoming an issue with wanting to increase protein in their diet, but some people are allergic to certain types of protein, so they're looking to diversify their protein intake. Now, of course, the producers are going to follow the consumer's demand, so they're trying to address that demand by identifying new sources of proteins and also maintaining a certain cost of production and trying to find where they fit in this market and how they can profit and be singled out. And also looking at valorizing byproducts. So by that, for example, we press oil, we press seeds to get oil. What happens to the meal? The meal is rich in protein. Okay, let's extract that protein and make it a high value ingredient. Replacing chemical ingredients and functional proteins, that means the notion of clean label. So shortening that ingredient list and putting ingredients that the consumers, when they read, they understand what they are. So having functional proteins that can potentially produce a product with clean label. We don't want to forget the growing population as well, and we want to feed the growing population sustainably with climate change in mind, with our environment in mind, and noting that the population is growing to about 10 billion by 2050. So we want alternative sources. Meat is not going to go away from our diet, but we need to provide alternative sources and think of regenerative agriculture as we do so. So where are we seeing the incorporation of plant proteins? We see meat analogs. This sector is growing so fast, and it was worth 5.6 billion in 2020, and it's going to grow with the high rate of growth of about 15%, reaching about 15 billion by 2027. So this is a huge market, and it is definitely looking for new and nutritious sources of plant proteins. Protein beverages, so the high protein beverages that are potentially used for athletes or for folks that are health conscious, so they want an extra dose of protein. This is growing, and by 2025, it's estimated to reach about 2 billion in market value here in the US. Other applications, dairy analogs, so anything that is alternative to milk, for example, like oat milk or almond milk, and alternatives to dairy cheese, plant-based cheeses using soy, for example, and now pea is gaining traction. Also, protein bars, high protein bars, and extruded products, breakfast cereals or snacks are also being produced with a high protein in mind. However, the consumers is trying to deviate a little bit from soy and gluten for many reasons that might include allergenicity, sensitivity, as well as those people that are looking for non-GMO. They might want to incline away from soy, which we have 90% of the crop here in the US is potentially genetically modified. So what are the proteins that are gaining traction? The list is huge. It's just a sample of this list. But if we look at pulses, peas, it rises to the top there, and I'll talk a little bit about it here in a little bit. And oil seeds, canola, for example, which is rapeseed in Europe. Canola is a genetically modified version of rapeseed, sunflower, and we are developing here at the University of Minnesota 2 new oil seeds with environmental benefit. They're winter crops, short season, and these are camelina and pennycress. Single cell proteins, as well as lab-grown protein, insect protein, and many others, including oats, hemp, potato, corn, almonds, and the list goes on. If we look at pea and why it's growing so fast, it's because it's easy to grow. It's a short season, can be in crop rotation, benefits the soil by fixing nitrogen since it's a legume. So it has many added value from an environmental perspective. From consumer perspective, they're going to think, okay, is it GMO? So far, it's non-GMO. So far, it's not on the list of the big allergens. I say that with caution. That's a conversation for another time. But it does have disadvantages. It has lower nutritional value than soy protein or animal protein. It has potentially flavor issues. Soy has more than 50 years of research. However, pea is maybe have 10 years worth of research, not yet enough to mitigate flavor issues. And also it has inferior functionality. So when I say functionality, I'm just going to put it in simple terms and trying to explain what do we want from proteins in our food. So plant proteins are complex, different than animal proteins. They can be large, globular proteins, and then they kind of associate in large forms, makes them really challenging to work with. What makes them really challenging is that they don't like water oftentimes. So if they don't like water, most of our food has water in it. So it's really hard to incorporate them. So I always call it the love-hate relationship, protein and water, which potentially provides challenges. So when we process the protein, the nature opens up and dislike water even more, which makes it really hard. They can form large aggregates, and then that means they cannot gel the way we want them to gel or emulsify or be soluble. So I'm going to show you a protein beverage. The protein has to interact with water, has to be soluble. So that's what we want the plant protein to be soluble. We put it in water, it stays in solution. You go buy it, the protein doesn't sediment. When you grab the bottle of high protein, you don't want to see sediments at the bottom. We also want it to gel. We want to produce plant-based yogurt. So we want to have a 3-dimensional network and entrapping water so that we can form our gel matrix. We want it to emulsify. We want to put oil or fats mixed with protein, liquid, aqueous. We want that all to be homogeneous. For example, the cream cheese or plant-based cream cheese. So we need the protein to be able to emulsify, to hold these different components together. Meat alternative, we want to texturize, we want to produce that meat, and we want them to form fiber shapes similar to meat fibers and also hold water within. So we are demanding a lot from these proteins, and they come with challenges. So we do research to address these challenges in a way that we can incorporate new plant protein sources, understand them, characterize them, and figure out ways to add them to our foods and still maintain the flavor, the texture, the nutrition. And also we need to identify upstream and downstream processes for these, to develop these protein ingredients and finally the product. So we want to understand how we can do that. Develop prediction models to link, we collect a lot of data and we want to understand if we measure one characteristics, how does that translate into a food product? So prediction models would be a very helpful tool. look at new opportunities, new applications for these proteins, and also investigate crop diversity and initiate breeding program to select for varieties that give us the proteins that have the highest quality. And while doing so, make sure we have abundant and sustainable supply. So what we do is we work on all of this at the Plant Protein Innovation Center. So the Plant Protein Innovation Center has a mission to attract researchers from different fields and work with the industry directly to innovate in the space of plant proteins, ingredients, and products, working all the way from production on the land to upstream, downstream processing, formulation to the end consumer. And we tackle challenges and opportunities identified by the industry in order for us to solve problems and provide innovative solutions. So the Plant Protein Innovation Center is growing very steeply. We tripled in size since the inaugural in 2018. We're a little bit 3 years old and a little bit over that. We have about 40 members, industry members. We have the partners from ingredient companies, B2B, CPG companies, and associate members, as well as supporters and collaborators. So basically, we do research from different disciplines. It's not just food science. We collaborate with agronomy, breeding, genetics, economics. So we bring nutrition, informatics, all of these different disciplines, and we have experts at the University of Minnesota. So we have experts in different fields that we can work together to innovate, because food is important and it's not simple. A lot of sciences go into the production of foods and also going into the consumer. So all of these different disciplines we have at the University of Minnesota, at CFANS, and also across colleges at the U. We have facilities that allow us to do very innovative type of research. We have our own labs. We have centers that allow us to do all of the ingredient production in pipeline, ingredient characterization in our labs, and in characterization centers at university. Our mission, we are educators, so we educate students that will become professionals in the field. And basically our students that come out of the center, they have a job offer before that they graduate, which puts a large stress on me. I'm very happy for them, but that means reading thesis is just ongoing 24 hours, 7 days a week to get them out and get their jobs. So we have so many students that are trained in addition to postdocs and research fellows at the center. And we also have undergraduate students from food science and nutrition, from different departments of the colleges, and also from other colleges that come to us, and we provide them training. All we say is a little bit of science and a little bit of enthusiasm, and then you're good to go with us. Examples of the research we do so many different research, but we focus on production of ingredients via viable and innovative technology that will preserve the functionality, the nutrition, and the flavor of our foods. We work with breeders and geneticists to look at different varieties, to develop the breeding programs, and we look at flavor characterization, nutritional quality during processing, between varieties, in the final product. And we try to enhance the functionality of the protein by innovative ways. We work with engineers for non-thermal processing, for example, and we try to come up with a clean label and friendly functionalization techniques to incorporate. We have our funding sources coming from members of PPIC, but we also have external funding that comes in to fund our research. And this is just a glimpse of our research group. And I thank you all for your attention. And I didn't know if I went over my 7 minutes. I probably did, but thank you.
No problem. Thank you, Pam, for sharing with us some of your cross-functional work in plant protein innovation and the potential impact that it may have on climate. Next, we'll hear from Yuxin Miao, who is an assistant professor in the Department of Soil, Water, and Climate and the associate director of the Precision Agriculture Center. Yuxin's group aims to develop integrated precision agricultural management systems for food security and for sustainable development. His research group uses a combination of field measurements, active canopy sensors, UAV, and satellite remote sensing, and crop growth modeling and other technologies to develop innovative solutions to improve ag resource management and to protect the environment. So thank you, Yuxin, for joining us today.
Thank you for the information, and it's my great pleasure to have this opportunity to talk about climate smart precision nitrogen management. We all know that world agriculture is facing great challenges. We need to increase food production to ensure food security, and we need to improve resource use efficiency, and we need to protect the environment, and we also need to increase the profitability of farmers. And at the same time, we are facing climate change. We need to adapt to climate change, and also we need to mitigate climate change. Precision agriculture is a promising approach to provide some solution to these challenges, and precision agriculture has been regarded as the next agricultural revolution. Precision agriculture is a management strategy that gathers, processes, and analyzes temporal, spatial, and individual data and combines it with other information to support management decisions according to the estimated variability for improved resource use efficiency, productivity, quality, profitability, and sustainability of agricultural production. So climate change is a major factor influencing crop production and has been considered in precision agriculture. To be simple, precision agriculture can be regarded as the spatial and temporal optimization of key factors influencing crop yield, profitability, and environmental footprint. Now let's precision agriculture try to optimize all the key factors. Now let's focus on nitrogen management. Nitrogen management is very important. It's needed by most plants by large amounts. And if we don't supply enough nitrogen, crop growth will severely limited and we will have very low yield. But if we apply too much nitrogen fertilizers, we will pollute ground and surface water. The crops will remain green, delay their maturity. And also we will have lodging problems, and we can also increase the disease and insect damage. And precision nitrogen management is very challenging. We need to estimate the crop nitrogen demand. We also need to estimate soil nitrogen supply. And then the difference will be supplied by fertilizers. And crop yield and soil nitrogen supply, they are influenced greatly by year-to-year wider variability. And also, nitrogen is very dynamic and can be lost in many different ways. They can, if we have rainfall, and the soil is sandy, and the nitrogen can be lost through leaching to the ground and pollute the groundwater. Nitrogen can also be lost through volatilization as ammonia. And also in clay soils and fine texture soils, and if you have a lot of waterlogging situations, you may have denitrification, and the nitrogen can be lost as nitrous oxide, which is an important greenhouse gas, which is about 300 times more potent than carbon dioxide. So we need to try to adapt our management according to the weather conditions, and at the same time try to reduce the nitrogen losses, especially in the nitrous oxide, to reduce climate change. So precision nitrogen management tries to match nitrogen supply with crop nitrogen demand in total rate. How much you need, we just supply that amount of fertilizers. We don't under apply because that will limit yield. We also don't want to over apply to waste resources, waste money, and also pollute the environment. But also we want to match nitrogen supply with crop nitrogen demand in space. A farmer's field is not uniform. It has different soils and different landscape conditions, and the nitrogen need is different. So we need to apply different amount of fertilizers to different parts of the field. Also, we need to match supply with crop nitrogen demand in time. Year-to-year weather variability, weather condition differences can have a strong impact on the crop nitrogen need and the optimal nitrogen rate. And we can see the optimal nitrogen rate can vary significantly from one year to the next. And also, even during the same growing conditions, crop nitrogen requirement is not uniform across the growing season. Crops don't need much nitrogen at the early growth stages. And then during in about kind of early July, the crops will need a lot of nitrogen. So we should not apply all the nitrogen before planting. So the nitrogen in the soil have a high risk to be lost. So we need to apply small amount at the beginning, and then during the growing season, based on the weather conditions and the crop growth conditions, we can determine how much nitrogen we should apply to optimize crop growth and also environmental protection and farmers' profitability. So we have been developing different strategies. So we can delineate a field into a few management zones using soil, landscape conditions, and also historical yield information. So each zone is relatively uniform. And then we can use the historical yield data and soil landscape data to characterize crop growth models. Then we can do simulations and the different weather conditions. What will be the optimal nitrogen rate? And we can also determine the long-term optimal nitrogen rate for different zones in each field. And then after we know this, we don't want to apply all the nitrogen before planting. So we only apply small amount, about 30% of the total optimal rates before planting to meet the early growth needs. And then during the growing season, we can use UAV remote sensing or satellite remote sensing to monitor the crop growth and to determine how much nitrogen will be needed in different parts of the field. And then we can make a prescription and use this prescription to guide fertilizer applicators to apply different amounts of nitrogen in different parts of the field. By this way, we can improve the nitrogen use efficiency, increase the farmer's profit, and also can adapt to climate change and at the same time to mitigate climate change and protect environment. So this is only part of what we are doing, and we are trying to integrate the nitrogen management with other management practices like irrigation, like variable seeding, variable planting, and also cover crops, and also site-specific tillage. So the Precision Agriculture Center was established in 1995. That's the first precision agriculture center in the world. And we are trying to work with commodity groups, companies, and collaborators within UIs and around the world to try to improve crop management to face the great challenges. And we have been also working closely with farmers to conduct on-farm trials to demonstrate the technology and also to facilitate the adoption of the technology by more farmers. Thank you for your attention. Any questions?
Thank you, Yuxin. We'll save questions for the breakout sessions. Thanks for sharing your work in precision agriculture management systems. I love the next agricultural revolution. Next, we'd like to welcome our final lightning talk speaker, Sue Galatowitsch, who is a professor in the Department of Fisheries, Wildlife, and Conservation Biology, whose work focuses on advancing the practice and outcomes of ecological restoration. Sue's group's current research is aimed at developing scenario planning tools for managing climate-sensitive species in protective areas, developing ecological resilience assessment tools for restoration planning, and determining how organizational capacity affects restoration outcomes, developing native seed harvest guidelines, and formulating management response protocols for newly invading species. Thank you so much, Sue, for speaking with us today.
Great, Annie, thanks for that introduction. Let's see if I can keep us on time. I'll be talking today about the Climate Adaptation Science Center that Brian mentioned, as well as Heidi. And I also want to bring to life just why a center can be so important as we're at this juncture, as Heidi emphasized, of needing to act very quickly in this closing window. The Midwest Climate Adaptation Science Center was established this past fall after a rather lengthy sort of, few years in trying to get a center just for the Midwest. And so what you can see in the upper left-hand picture here is the network of different regions that form the USGS, the federal partner for our climate center, the different regions that have climate adaptation science centers. And until this past fall, we were actually combined into the Northeast, which didn't sit well with many of us, including some of our leaders in Congress. We really needed a center to be able to focus on what makes the natural sources of the Midwest special and important. For instance, our Great Lakes, our boreal forests, our large rivers, our urban natural areas, as well as all of the natural resources that are out in the very extensive agricultural reaches of the Midwest. The goal of these centers, and certainly ours, is to link science, the science that we do at universities like the University of Minnesota, to community decision makers to enable climate adaptation for natural resources. We are focused on natural resources, fisheries, wildlife, forestry, and so forth. Our consortium that basically leads this center and tries to make this happen are 5 major universities: the University of Minnesota, Wisconsin, Michigan State, University of Illinois, and Indiana University, along with several really important partners for our region, which includes the College of Menominee Nation and the Great Lakes Indian and Fish and Wildlife Commission to help us make connections and work on tribal lands, as well as the Nature Conservancy, which has a distributed land management sort of presence across this Midwest region. Oops. Okay, so as soon as we found out we were going to have a funded Midwest Climate Adaptation Science Center, even before the University of Minnesota was selected as the host, as well as our consortium that I introduced you to, even before that happened, our federal partner reached out to the decision-making stakeholders in the region and came up with a basic scoping of what should be the science priorities for natural resources in the Midwest related to climate adaptation. And they came up with 7 really important topical areas. Things like we need to be worried about floods and droughts, in particular drought impacts to our forest systems, our forest production systems, loss of winter, which I'll talk a little bit in a bit, impacts to fishing and hunting. It's hard to pick up the Star Tribune and not see an article of fussing about what's going to happen with walleye? And that's a big one in our region. Altered hydrologic regimes, a big one for things like wild rice and tribal communities. Novel ecosystems, what happens when invasive species run amok and create sort of real strange and new places, everything related to the Great Lakes, and certainly all of our tried and true management tools, how do they work in an era of a changing climate? So we have these science priorities in general. They will take, each one of those topical areas will take many, many science projects to begin to address those needs. But basically then, how do we link that to basically communities that need to basically make decisions to be able to do that adaptation? So critically, what kind of science do we need to generate so that we basically provide that information so that communities can adapt? So what does it take to adapt? What is our role in achieving climate change readiness in the Midwest? We know that decisions about natural resources really can't rely on established norms. We know that many decisions not primarily about natural resources have the potential to be maladaptive to natural resources. So for example, there's a lot of federal money coming into local governments right now for infrastructure improvements, many of those targeting climate impacts from sort of really major storm events, urban flooding, shoreline erosion. And if we aren't paying attention to it, some of those new solutions, those new engineering solutions, could actually do unintentional harm to natural resources, coastal communities, as well as aquatic systems as examples. So we need to figure out how to bring scientists and communities together to build this decision-making capacity so we can have this promising, sustainable future despite changes in climate. What we know so far is that almost all of the science in the natural resource sector really fits into one phase of this adaptation cycle, which you see on the right. The adaptation cycle, as you see here, we basically need to diagnose what are the key vulnerabilities of our natural resources. And that needs to be based, of course, on climate trends, which Heidi introduced you to the importance of having that information. The assessing vulnerabilities is really about figuring out what aspects of the ecology are going to be most seriously affected potentially, and then to communicate those risks and opportunities out there to the broader communities of the Midwest. But it can't stop there, and that's basically where most of our research has happened in the past, say, 20 years, since we've understood the need to adapt. The other phases that our center needs to be involved in from a science and decision maker perspective is the next phase, which will be planning, helping communities identify their adaptation options and developing adaptation approaches. And then when communities decide to act, then supporting them with science related to evaluating and monitoring the effectiveness of those. So Annie mentioned that one of my interests is working on climate vulnerable species. One of those is small white lady slipper, which occurs out in southern Minnesota in remnant postage stamp prairies surrounded by agriculture. So not a lot of space left, and Minnesota has the biggest population of this species in the world. We knew it was vulnerable, and where I came into the picture was to evaluate adaptation options, highlighting and comparing the importance of changing invasive plant management regimes, practices, because that's a really important aspect of keeping those populations okay, as well as possibly buying adjacent land to keep the sort of water flow sort of at a better point for the species. So we identified those two features and realized how important it was going to be to change their invasive species management approach. And now it's in the hands of the decision makers who are responsible for those populations, mostly public land managers. And when they decide to act, then we can be there to help them evaluate whether it's working as we predicted, whether that small white lady slipper populations will show trends of stability, not decline. So then it comes down to who's acting and who's already trying to use what information is out there to get ahead of climate change and sort of who are the actors in this space. And really right now, there are two groups that stand out for leading the way and actually taking action on adaptation plans. And one of those certainly are local communities, in part because they're feeling the pressure from urban stormwater flooding and coastal zone erosion and lack of tree cover, and therefore less climate refuges for vulnerable populations. And then also tribal communities. Tribal communities are way out ahead of pretty much everybody in formulating very robust climate adaptation plans, and then really seeking guidance on how to evaluate whether the plans they're taking are working. And we expect the sort of who is leading the way to then expand out to many other sort of communities around the Midwest. So what's the role of a climate center like the one we've launched? This diagram, I think, sums it up to some extent. We have really thousands and thousands of different communities across the Midwest region, from small towns on Lake Superior and Lake Michigan to basically communities that depend on forest resources as examples. The cities of Minneapolis and Chicago, and I could go on. Basically communities with decision makers that have knowledge gaps that they need attention to. And how do they basically get linked up to the experts in our university system who could do useful research? So in many ways, these are 5 major universities need to come together and connect with those decision makers, oftentimes with the support of some of our other consortium members as well, like the Nature Conservancy and our tribal members. So one of the big things that we do in the Midwest Climate Adaptation Center is connect people. The second thing we need to do is capacity building. In many ways, we need to train our scientists to be able to co-produce research in a way they haven't before. And when we do produce research, we need to communicate that research to those decision makers in a form that's usable. We need to synthesize the available knowledge and use it to make tools that help decision makers. And then because we do have access to funds to fund research, that's a really good way to incentivize all this working together that I'm talking about. Okay, so our center is new, but we already have about 15 active projects that are taking up some of these topics. And we have about 33 graduate students and 17 postdocs that are part of these teams. And so we already have a good start. A couple examples of our projects that are underway, a couple that are led by the University of Wisconsin are about the loss of winter. That snowshoe hare that you see here, as well as ruffed grouse, are 2 really important species of wildlife in the region. They both undergo phase shifts from white fur or feathers to brown fur and feathers, timed with when the snow usually is on the ground or not on the ground. And so what's happening now, we're losing winter faster than those species can evolve. And through some really important research coupled with our tribal communities, we've learned that we are probably going to lose those populations at a very high rate if we don't think about having snow refuges across their home range, as an example. Another example is altered hydrologic regimes affecting key aquatic organisms like wild rice. That's hugely important for the Ojibwe communities. And so some of our researchers are basically collaborating with our tribal communities in northern Minnesota and northern Wisconsin to figure out how we can reduce other stressors and adapt other practices so wild rice has a fighting chance to stay. That project is led out of the University of Minnesota. And there are many others, but I just wanted to give you 2 examples, and I'm way out of time, I know, which is good. I'm on the last slide. So I wanted to emphasize that the Midwest Cast is hosted at the University of Minnesota, led by scientists in CFANS, including Heidi and I. It's also basically the hub, the main hub is at IONE, and NRI and Duluth is a key partner at Minnesota as well. We have 15 overall science leaders across our consortium that I showed you at the beginning, and we are funded by the USGS, most natural resource work, is typically funded in the public sector. If you have any questions about the talk today, here's my credentials. I'm super easy to find, and I'm with FWCB and CFANS.
Awesome. Thank you so much, Sue, for sharing your work on the Midwest Climate Adaptation Science Center with us today. We really appreciate learning how CFANS is helping to link the climate science to community decision makers and how we are actually putting things into action. So now we are pleased that 3 of our speakers are able to answer questions in breakout rooms for 10 to 15 minutes. I encourage you to stick around with our faculty. You can hop between breakout rooms to ask questions of different speakers. You can navigate to the different rooms by clicking breakout rooms in your Zoom window, and then just select the room that you want to join. Unfortunately, Pam had to depart early, so if you have any questions for her, please share them in the chat and we will follow up after the event. So we'll see you back here in, I think, 15 minutes. If you have any trouble selecting a breakout room, just use the chat function and we can direct you where you want to go. You can just tell us what individual room you want to go to, and we will manually send you there.
Anyone still in the main room that would like some assistance getting to one of the breakout rooms?
As everybody comes back into the main room, if you could just answer the poll quickly, we really appreciate your feedback. Thank you. Assuming that everyone is back, I just want to say thank you again to everyone for attending. Thank you so much to our speakers. We really hope you enjoyed the conversations in the breakout rooms. Getting some of that direct engagement with our faculty is really, really a cool opportunity. So just thank you so much for all the great discussions this afternoon. It's just awesome to learn more about all the climate adaptation and mitigation research that's going on within our CFANS faculty members and our college. And so I'm just going to turn it back over quickly to Mary for some closing remarks.
Excellent. Thank you so much, Annie. As we wrap up today's program, I just would like to acknowledge Annie Makepeace, who's been a champion for the Classes Without Quizzes program for the last several years. I also want to thank the speakers for taking your time to share your research and insights with us, to Meredith Dwyer, the behind-the-scenes technical expert, for your work in facilitating the program, and to all of you for joining us today. I also wanted to point out on the screen, there are a couple of events coming up. Borealis Night of Excellence, where we recognize our community and alumni and student leadership and accomplishments on April 21st. That will be one of our first in-person events taking place on campus, so I hope you can join us. For those of you who might be interested in supporting students, we have a tremendous mentor program that matches students with professionals, and students, we mean undergrad, grad students, and even postdocs. So if you're interested in being a mentor, check that out. And then be sure, if you come to the Great Minnesota Get Together in the fall, come see CFANS at the State Fair. So with that, we look forward to seeing you at the next Classes Without Quizzes program, hopefully in person in April 2023. Have a great day.